All right, so we'll kind of pick up where we left off. Uh, Last class, I'll do some things. Second, got all my markers. I'll do some things that kind of look like review from last class. Kind of try to set us up for what we're going to talk about today, and then we'll kind of finish out module 2. I don't think we'll have any enough time to kind of start module 3, but we'll start that tomorrow. So one thing I wanted to mention before we get going is there was a small issue with module 2 reading. I double checked all the other ones, and for some reason, it was the only one where this setting was turned off. It was not showing you the answers that you got incorrect. It was telling you, you didn't have the full points, but not which ones. So I'll go back and kind of look at those. As long as you kind of got that submitted on time, I'll give everybody credit for that full credit for that module reading. From here on out, it should show you which ones you got incorrect and which ones you should be taking a second attempt on. So we've got that out of the way. Anything else? Any questions kind of before we start? So we've got the participation quiz, which we'll look at here later today. Module 2 quiz will kind of pop up after we are done with class today and cover module 2 material. You'll then have module 1, module 2 quiz. I wouldn't necessarily save them all for Sunday night, but due by the end of the day on Sunday. Okay. Any questions before we dive into material here? Okay. So we left off thinking about kind of points that were inefficient, unattainable, production efficiency. So kind of pick up where we left off. I'll mention this idea of allocative efficiency as I draw out an example for you, and then we'll kind of revisit this once we are done. So I'm going to stop this and then share this with you. All right. So we had this example last class where we were thinking about production possibilities curves, how those might differ with countries. So I'm going to do kind of a slightly different example today, thinking about instead of countries in a worldwide economy, individuals within like a smaller economy. And so I had this example. So I've got two individuals, me and my wife. And we currently have a 7-month-old baby. So we're doing a lot of diaper changes and a lot of feedings. Right? So this kind of is a slightly, less technical example, but it applies to anything where we're making the choice between two different products, two different activities, and have two individuals. So before last class, we did countries and, agricultural products. I think it was wheat and computers or something like that. So here we just got slightly different products, right? So I can think about here, let's do, I'll keep this consistent. So I think something like this, okay? So I'm going to think about, if I was drawing out the production possibilities curve for these two individuals, right, what would it look like? Well, I'm going to put feedings on my x-axis, diaper changes on my y-axis. Okay. So actually, do I want to do that? Yeah. So, excuse me. If I'm thinking about Sam, right, individual 1, all of her resources, if she was only using her time to change diapers, she could change 40, only feed our child 20. Right? So that would be her production possibilities curve. Now, for my production possibilities curve, right, we're looking at what? 60 if I'm only changing diapers, 15 down here if I'm only feeding. So one thing that we didn't have an example of last class, I think the example last class was you had an absolute advantage, one person had an absolute advantage in everything. The intercepts tell us who has an absolute advantage in the production of these different goods. So those kind of diapers and feedings here. Who has an absolute advantage in feedings? Well, who, using all the resources, can produce more? Remember, Robert is blue here. So that would be Sam, who can change more diapers if they're using all the resources. That would be me, right? Robert. So the intercepts tell us about who has an absolute advantage, but we said when we're starting to think about who's going to first start producing a good for an economy, we want to know who has the comparative advantage. So how did we determine who has a comparative advantage? That was whoever had the lowest cost to producing that good. So we said we can calculate the cost of our x-axis good by determining the slope of that production possibilities curve. So here I've got what? Change in y over change in x is how I calculate the slope. So for Sam, the y value is going down by 40. The x value, oops, is going up by, remember this is the 0 point, going up by 20. So the slope is -2. Slope for our other individual in our economy has what? -60 over 15 or -4. So remember, when we calculate these slopes, they will be negative. But when we're looking at these values, they represent costs. So costs are inherently negative. So really the cost to this x-axis good so the cost to Robert of a feeding is what? 4, and it's in terms of the y-axis good. Okay. Then if we're thinking about Sam, her cost of the x-axis good, just feeding here, would be 2 diaper changes, right? So who has the lower cost? Sam. So we would say that Sam has the comparative advantage in the production of that good. Okay. Any questions on that before I keep moving here? All right. Now, there's two ways of then figuring out, well, there's a couple different ways. One, if we can remember, you can only have a comparative advantage in one good, right? So if Sam has a comparative advantage in feedings, that means that Robert must have the comparative advantage in the other good. Now, how can we prove this? Well, that would have to mean that he has a lower cost. So one thing we could do is like flip what good we have on the x-axis and rework all of this. Or we can remember that the cost of this y-axis good is 1 over the cost of our x-axis good. So if we wanted to do that here for Robert, the cost of the diaper change or the y-axis good would be equal to 1 over 4. And then for Sam, it would be 1 over 2. Which of these values is lower? 1/4. That's why we would say Robert has the comparative advantage in the production of the other good. Okay. Any questions there before we kind of keep moving? So once again, kind of a review of some stuff we talked about last class, but I'm going to build out like a more comprehensive full model here in just a second. All right. So with these values in mind, if I can get this, there we go, not finger flub. So let's say we wanted to look at, actually, let me pull this out so I can reference it. Let's say we wanted to look at not each individual's production possibilities curve, but the entire economy. So in my economy, it's just 2 people in my household. So it's like a household economy here. If everyone in that household, every individual in the economy is only changing diapers, how many total could we change? 100, right? 40 plus 60. What about feedings? 20 plus 15 would be 35. So we can always determine what those 2 intercepts are by simply adding up the total amount each individual in the economy can produce. Those are the easiest points to determine whether or not they're on our production possibilities curve. Now, when we start to look at an economy-wide production possibilities curve, where we're looking at more than just one individual, we said, who are we going to rely on to first start producing that x-axis good, or to first start producing or kind of doing these feedings. Well, who could do it at a lower cost? We said that comparative advantage was Sam, right? It only cost her 2 diapers. So initially, the slope of our production possibilities curve is going to be -2. Right? Now, we're going to get to a point where Sam is now using all of her resources to do feedings, which means she is no longer doing any diaper changes. We would lose those 40. So that point where each individual is only doing what they have a comparative advantage in, that's going to be this point in the middle. If we want to go any further than 20 for our x-axis good here, or we want any more additional feedings, well, Sam's used all of her resources. I'm going to have to now start relying on the second person in my economy, and their cost was 4 diapers, or the slope of their production possibilities curve was -4. Right? So this is how I take 2 individuals and produce this economy-wide production possibilities curve. So these 3 points are usually the easiest to kind of determine. If they're only producing the x-axis, both people are only producing the x-axis good, both producing only the y-axis good, each producing what they have a comparative advantage in. Any questions on that before I add in some additional wrinkles here? So there's some questions on the practice problems for the Module 2 quiz, and might be a question that looks like, has a similar question on the Module 2 quiz and potentially then on the exam 1. Which of these points, lists a couple points, which one's not on the curve? We know these 3 points are on the curve. What if I asked you, is the point 25 feedings and what do I want here? Let's say 50 diaper changes is on that curve. Well, I don't know, right? Without doing the math, because, oh yeah, if I want a few more feedings, I'm gonna have to give up some diaper. Okay, it looks like maybe it could be, but I'm not really sure, right? Maybe that point's down here, maybe it's above here. All the points that are on the curve are when we're using all of our resources. So we will start out assuming, okay, if I want to get to 25 feedings, I know I've already used all of Sam's resources. So who am I going to be relying on? The other individual who has a cost of -4 diapers, right? So if I want to go from 20 to 25, what's the additional number of this x-axis good I want? 5. Each one is costing me 4 of that y-axis good. So I'm going to have to give up 20 diaper changes. So 60 minus, excuse me, and this might not be quite drawn to scale, but 60 minus 20 would be what? 40. So the point that's on the curve, if I want 25 of that x-axis good, would be a value of the y-axis good of 40. So 2550 would actually be at a point above that curve, or what we would say is unattainable. Okay. And I could determine all the points, right? 26, what point would I be on the curve? 27, etc. Right? Same kind of method. Now, I could also give you one where I said, okay, what about if we were at 10 feedings and, I don't know, 80 diaper changes, right? Well, I don't know if that point's on the curve or not. I can check if I want to get to 10 feedings, what point would be on the curve? Well, I'm relying first to get those first 10 on Sam. Haven't used all of her resources yet. So each one is going to cost me 2 diaper changes. So the total cost would be 20. So if I go from here to here, I'm losing 20. So 100 minus 20 would be what? 80. So sure enough, that point of 1080 is on the curve. Right? So sometimes these points, I can check them. They will be on the curve. Sometimes they're not. If I instead had said, 1060, what would that have represented? That would represent a point that we said is production inefficient. Okay. Any questions there before we keep moving? Okay. All right. So with this side, this is just one thing I know that I'll ask you questions about how to check if different points are on there. We did kind of build out one of these, like adding the individuals up to look at the economy-wide production possibilities curve, but I wanted to go through another example just with some different values and some different stuff. Okay, this light's turning off on me. So let me go turn it on real quick so I can see what I'm doing. And I need to email building support to figure out if there's a way I can set that so it doesn't be on the automatic switch on and off. All right, so the next thing that we're going to look at is every point on this production possibilities curve is what we would call production efficient. Okay, so if I'm looking at any two goods, it doesn't matter what those two goods are. Okay? Here's my production possibilities curve. Okay, we said that in a two-person economy, notice what was happening. Oh, I slid it back here. What was happening to the slope of our production possibilities curve? It was becoming steeper. Same idea applies if we don't have just two people in our economy, but let's say we have millions. I first rely on who produces at the lowest cost, next lowest cost, next lowest cost. This could be like a bunch of different individual production possibilities curves to get the total economy-wide production possibilities curve. So my slope, it's getting steeper. So another thing we kind of alluded to or looked at a quick glimpse of last class, if I can write X, there we go. What does the slope of my production possibilities curve represent? We said it represents the opportunity cost of the x-axis good. So what's happening to the cost of this y-axis good as I produce more of X? Sorry, the cost of the x-axis good as I produce more of X? My marginal costs are going up. Okay. So I can choose all, any point on this curve and I'd be using all of my resources. Every point here would be production efficient. But what point is allocatively efficient? So kind of back to our example like last class, if I'm thinking about this guns and butter example, if I'm only putting money towards my military and not feeding my people, they revolt. So that's probably not what we would call an allocative efficient point. Yes, I'm using all of my resources, it's production efficient, but allocative efficient means that I am choosing the combination of these two goods that makes my society the best off, right? Or provides my society with the highest benefit. So in order to determine so I know I don't just want guns. I know I can't just put money into these agricultural products, otherwise I'll get invaded, and that's not good either. So as I am moving in between these 2 points, there's some point on here which would be the best point for society, right? It'll feed my populace and also keep them safe. So how do we determine what that is? Well, we would need to know something about not just the marginal cost, which the production possibility curve tells us. We would also need to know what are the marginal benefits of producing more of this x-axis good. Okay, so this is going to be a little bit trickier to figure out. We won't really dive too deep into how we calculate the marginal benefit, at least right now. But the idea is that we will want to have down and will want to understand is the idea that the very first couple agricultural products I produce, I'm going to start feeding my people. Those have a huge benefit. They're going from no food to some. Now, eventually I get to a point where if I've got a lot of agricultural products or butter, people aren't, people are already full. They're just overeating. Maybe it's not near as large of a marginal benefit. So we assume that when we have more of something, the marginal benefit is declining, or this is the law of diminishing returns, or law of diminishing marginal benefits. We'll look at this in a slightly different context later on in today's class. So we talked about last class, people should choose to buy something, put another hour towards an activity as long as that marginal benefit is greater than the marginal cost. So, and we said they'd stop at the point where marginal benefit is equal to that marginal cost. So this point here would be our allocative efficient point. And I'll just kind of start abbreviating that with AE. Now, we could map this out, whatever quantity this is, it would correspond to this point on our production possibilities curve. So this would be our allocative efficient point. And we can get that from looking at the marginal benefits and then determining the marginal cost using the slope of our production possibilities curve to figure out where that allocated efficient point is. So all these points are production efficient, but only one of them is allocatively efficient. Okay. Questions on this before we keep moving here? Okay. So we'll go back into slideshow mode here. So these allocated efficient points, we said it's going to be kind of like our decision making that we were using last class, where marginal benefit is, we do something as long as it's greater than or equal to the marginal cost. So we'll go up to that point where they're equal. That's the allocated efficient point that's best for society. Now, this hinges on the idea that we have diminishing marginal benefit. And of course, we looked at that production possibilities curve. We know that the marginal costs are increasing. Okay. And don't worry, I changed the example here from Song's side. I thought, the guns and butter was kind of referencing last class and made a little bit more sense. Okay. So we drew that out. All right. Now, what's going to happen if we start to have changes in our production possibility curve? So one of the changes we can see, and it's not quite as interesting, I think it'll make a little bit more sense and then spending more time on the other type of change, is let's say I have an outward shift in this production possibilities curve. So what might cause, if I'm using all of my resources to produce either X or just Y, what might cause the intercepts to both increase? Well, if I have a technology change that impacts the production of every good equally, then if I'm only producing one good, I can produce more of it. If I have more people, population growth, I now have more labor hours to devote towards the production of that good. Doesn't matter which good I'm producing, I can now produce more of it. Maybe changes in productivity. So technology generally changes productivity, but you can kind of think about even a non-technology change. Let's just say my people are improving their knowledge or getting more what we call human capital, right? They're becoming more productive, even though there's no new technology, they're just becoming more knowledgeable. So changes in productivity could impact, no matter what they put their mind to, they can produce more of it. Okay. So all of these things, anything that changes that would impact both goods equally, we get this kind of nice shift out in our production possibilities curve, right? It's going to increase both of the intercepts. In fact, I don't know why my images, I think it's a compatibility thing, but this probably makes a little more sense, right? You can see the arrows, it's increasing. So there, I can, if I think about where would the kind of cost, even if the costs remain the same. So remember, when we were choosing that allocative efficient point, that was, marginal benefits and marginal costs. Well, potentially, if I want to look at that same marginal cost, it actually would now be at a higher quantity. And so my allocative efficient point might increase. But in this scenario, I might be able to get more of X and also more of Y because I had this shift in my production possibilities curve. I'm not moving to a new point on the old curve. I get to move to a new point on this higher curve. Okay. Questions on that before we keep moving here? Okay. So even if our marginal costs don't change, right, that slope stays the same, we can get more of both goods. Now, what's a little bit trickier is if I have an example where I've got a technology change, or even this could be, a worker productivity change, but it only impacts the production of one good. Okay. So I'm going to use this example of iPhones and wheat here. Okay. So if I use all of my resources with this new technology, it is only impacting the production of iPhones. And it doesn't have any impact on the production of wheat. Right? So you can imagine, I don't know, this is like they discovered some new material for the battery that, or not the battery, I guess. This would be something that, I discover some new production method that I can produce more iPhones with the same labor hours, but that production method doesn't apply at all to, harvesting wheat. Okay? So we're using all of our resources, we get the same amount of wheat, but if we're using all of our resources to produce iPhones with this new technology, we can produce more of that good. So what is this going to do? Right? So what is this shift or change in our production possibilities curve going to do? Well, we can think about kind of similar to before, you can see, well, there are points where I could get to higher amounts of both goods, but that's not necessarily want to think a little bit hard about, well, where does the allocative efficient point move, right? So you'll notice here, and I'll draw this out again, but like well, it's harder to see here, but what's happening to the slope if I were to look at any one quantity of wheat here? So I'll draw this out. I think might make it a little bit easier to see. What do I want to do? I want to stop share. There we go. So, and I'll kind of highlight some other things as well. So let's say I've got my example where I've got the quantity of wheat, quantity of iPhones. We started out, here was my original production possibilities curve, okay? After this technology change, here's my new production possibilities curve. So I'm looking at the same quantity before the marginal cost or the slope would have been, depicted with this line. Afterwards, the marginal cost or the slope of my production possibilities curve at this quantity now is a little bit, what? Steeper. So a steeper slope would imply at the same quantity, what's happened to my marginal costs? Well, the slope is the marginal cost of my x-axis good. So the cost of my x-axis good has went, so cost of wheat has went up, right? That was the cost of my x-axis good. Now, before I kind of go further, I want to mention one other thing here, which is if the cost of my x-axis good goes up, so I have this new technology, doesn't impact wheat at all, only impacts iPhones. It makes using the same resources to produce wheat, I'm now giving up more iPhone production than I was before. So the cost of wheat is going up. But remember, how do we find the cost of our y-axis good? That would be equal to 1 over the cost of our x-axis good. So if the cost of the x-axis good is going up, 1 over that, a larger denominator, the cost of our y-axis good is actually going down. Right? So when you have a technology change, whatever good it impacts, the cost of producing that good, the opportunity cost, will actually be lower, right? Because now to get the same one iPhone, it requires fewer labor hours, so I don't have to give up as much wheat production. However, whichever good does not experience that technology change, it now becomes more costly to produce that good. Okay? Any questions on that before we keep moving here? Okay. So I then want to connect the dots. Let's say I want to figure out where the allocated efficient point of wheat production is. So before, somehow I have information about what the marginal benefits of each unit of wheat is. It would be kind of follow this law of diminishing marginal benefits. And then I take the marginal cost at every single quantity. They're increasing. Where would the initial allocated efficient point be? Where marginal cost is equal to marginal benefit. Now, what did we say is happening at every quantity? That slope of my production possibilities curve is becoming a little bit steeper. Or at every single quantity, what's happening to my marginal cost? They are increasing. So if I have higher marginal costs, where is my new allocated efficient point? It's going to be at a lower quantity of wheat. And this intuitively kind of makes sense. If the cost of something is going up, am I going to want more or less of it, right? More or less than I had before? I'm going to want less, right? If the cost of it is increasing, I'm going to desire less of it than I did before. Okay. Any questions on that before we keep moving here? And we could do a very similar thing. So let's say I was wanting to, instead of thinking about wheat, let's say I asked you the question about what's the allocative efficient point for iPhones? Well, before the costs were whatever they were, so we had this allocative efficient point. What's happening to the marginal costs of iPhones? Oh. Well, we said if the cost of the x-axis good is going up, what was happening to the cost of the y-axis good? It was actually going down. So after this technology change, at every quantity of iPhones, my marginal cost is actually lower than it was before. So with this technology change, the allocative efficient quantity would actually be a little bit higher. Okay. Once again, this I think follows kind of intuition. Whatever becomes relatively more costly, I'm going, the allocated efficient point will be lower. Whatever becomes less costly compared to before, the allocated efficient point is going to be higher. Okay. Now, I'll only ever do this for these two good kind of models. It becomes more complicated. If we had three, it would be like a three-dimensional curve, and the math gets harder, but we'll kind of stay here. Okay. We'll restrict it this, but the same logic would apply. Okay. Any questions on this idea before we jump back to the slides here? Okay. All right. So there we go. The next thing we're going to talk about is or dive into is kind of economic growth. So I think I left this kind of slide open. Thinking about how do we get economic growth? It's investing into not what we call consumption goods. So consumption goods are things like food, where once it's produced and consumed, it's gone, right? There's no future benefits from the production of that good. Capital goods would be something like, well, I've invested money into research and development. That might not have initial increases in output, but I know that down the road, it'll make me more productive and lead to even larger increases in output in the next 10, 20 years. Okay. So every economy has this choice between investing into capital and consumption goods. Right? Investing into capital goods allows us to have some economic. If we only invest in the consumption goods, whatever we produce today is gone tomorrow, we don't have any growth. Right? So we can kind of analyze the choice between consumption and capital goods, just like we did the production of any other two goods. Right? We can look at the production possibilities curve there. Okay. So once again, we'll think about, all right, instead of having two specific goods, I can think about, I'm really making a choice between investing into these two different categories, consumption and capital products. So we would still have a production possibilities curve, right? The amount I'm investing into both consumption and capital. We could then think about, all right, all of these points are production efficient. Which point is allocatively efficient? Well, or how much should I be investing into these capital goods? Well, the slope of the production possibilities curve still getting steeper and steeper, so my marginal costs are going up. And then you can think about, and we'll look at this in a second, something that'll support this, but to relate it to something we already talked about, when I'm thinking about investing money into projects that I think are going to cause growth, which one would I invest in first? The one that I believe is going to cause the most growth, right? That the first $100 that I, transition over from consumption to capital goods, I'll put it towards the projects I think would have the highest additional impact on my society or increase my benefit the most. And then the next $100, I'll put in the next most useful project, and then the next most. So what's happening to my marginal benefit as I invest more and more? I'm investing into less and less effective projects or less and less effective capital. So I'm going to have this downward sloping marginal benefit from the investment in capital as well. This looks almost identical to what we were just doing. We could identify this allocative efficient point. Okay. Any questions on that? So we can get these marginal costs just like we did before for any two goods. It's just now the two goods we have are like bundles of goods, like consumption or capital goods. Okay. Now, from there, we want to think about not just the marginal costs. With investment into capital, we also have a graph that allows us to determine what the marginal benefits of investment into capital are. So let's say we have all of these things. So capital, so this is investment into machinery. This could be investment, like I said, into research and development of different, different products or ways to even, putting money into infrastructure. I also have labor. That's just kind of what we have been talking about already, like labor hours, right? My populace. If I have more workers, I can get more output. If I have more capital, right? Capital being machinery, I can produce more things. If I have more oil, I can produce more gasoline and, like I forget, like something crazy, like how many products, like all plastics, right, need oil. So natural resources will increase my output if I have more of them. Human capital, right? I think about if I have a more educated populace, right? The same labor hours, those people are more productive. That would increase my output as well. So even if my labor, the number of labor hours I have is the same, increases in human capital, I could get more output. Okay. Oh, hit the scroll button instead of the click button. And then, so all of these things, right? My output, Q, is a function of all these different things, right? Capital, labor, natural resources, human capital. Even if those remain the same, but I all of a sudden now have a new technology, I'm not going to get the same level of output I was before. I'm going to get that same level scaled up by a certain factor. So A is generally always going to be above 1, right? And if we have that increase in technology, it'll take whatever the output we were getting before and increase it by even more. So it has to be a number above 1. Okay. And this isn't something I'll necessarily quiz you on. This is probably, this is a general form of a function. We won't look at this too much throughout the semester, but here thinking about output is a function of these things. That function then gets scaled up if we have advancements in technology. So with this idea in mind, if I were to graph out output and my choice of one of these, right? So I'm going to kind of focus on capital here. So if I take the amount that I'm investing in capital, how much is that going to change the output I'm getting per hour worked? Right? So the investment in capital per hour worked, the output that I'm getting per hour worked. Well, the first $100 I invest, I'm going from, if I don't put any money to my worker, like let's say I have a factory, if I don't put any money into capital, I don't give them a building, I don't give them any machines to use, and I ask them, hey, go out and produce me, I don't know, something as dumb as like, we could do glass bottles, right? They can't produce any, right? Now, as I start to give them more capital, more machinery, a place to work, they can start to produce more and more output, right? More and more of these glass bottles. So initially, the first $100 I invest, I'm going from 0 output to 500. So for every dollar I invest, I'm getting some additional output. Well, if I invest $100, I get 500 additional units. How much was each dollar getting me? Well, I would divide these both by 100 and I'd say, oh, the marginal output is 5 here. Or what then would represent the marginal output? If I took the change in Y over the change in X, which is how I came up with this marginal, oh, that's just the slope of this macroeconomic production possibilities curve. So the slope of this macroeconomic production possibilities curve, the investment into capital and the output I'm getting per worker, that tells me the marginal output for every dollar invested. Okay. Now, what do we notice is happening? So the first $100 I put towards the capital I thought was most important and most effective for my workers. It allowed every hour worked, I could now produce 5 units. The next project or the next capital I invest in, or the next machinery I invest in, will be the next most what I think is efficient or useful capital investments. So that when I go from $100 to $200, my output's only going from 500 to 900. It's only going up by 400. So 400 over 100 to get that slope. Now my marginal output is only 4. And if I keep on going, now it's going from 900 to 1200. 300 is the change in Y over 100 change in X. I'm getting a marginal output of 3. So what's happening to my marginal output? As I invest more and more into capital, the additional output is going down. Or I can think about this as, what is output to an economy? It's the additional benefit. So I've got this law of diminishing returns, the same kind of law of diminishing marginal benefit that we talked about earlier, really applies here to capital investment. Okay? So with this idea in mind, that's where that diminishing marginal benefit to investment in capital comes from. Let's not be moving around enough today. Need to flail my arms a little bit more to keep these lights up. All right, so actually, let me see if I hit this. This might keep them on. There we go. Yeah. So one thing, and I've got this in the slides, but another thing that we can see happen is, and I'll draw this out. Actually, I'll connect some dots. So we had this idea of allocated efficiency before. If I instead kind of do these side-by-side graphs where I'm looking at capital on my x-axis, remember, these marginal costs came from our old, this regular kind of our production possibilities curve, how much we were investing into capital and consumption. Our marginal benefit is going to come from this macroeconomic production possibilities curve, where we were looking at kind of what? Output per worker, and then this was like capital investment technically per worker here. Right? So here we said it looks something like this, where its slope is decreasing. That was where we were coming up with these diminishing marginal benefits to investment in capital. So if before this was our allocated efficient point, what happens if we have a technology change? Well, remember, we had that output function. We said, even if I keep investing the same amount into capital as I was before, if I have a technology change, that gets scaled up by, I believe, what represented that was A, right? A times whatever that production function was. So if I invest the same amount in capital, but I have this new technology advancement, I can get even more output. And that is going to be true at every level of capital investment. So what's happening to my macroeconomic production possibilities curve? It would be increasing. Well, if this is increasing at every single point, what's happening to the slope? It is getting slightly steeper. Well, here, my macroeconomic production possibilities curve isn't telling me something about the marginal costs. It's telling me about the marginal benefits. So at every quantity of capital invested, if the slope is now higher, that means the marginal benefits are now higher. So that's like an increase in my marginal benefits, which leads to the allocated efficient amount to invest in the capital being greater. And once again, intuitively, this kind of makes sense. If investment into capital is going to have even more of an effect on output, it's going to add a higher amount of additional output, then I'm going to want to invest more in it. And that's what our allocated efficient point tells us, that when we have this technology change, capital becomes more impactful, whereas leading to higher additional levels of output, we're going to want to invest more in it because that's essentially that additional output will be an increase in our marginal benefit. Okay. Any question? I feel like I'm talking a lot. I want to make sure I give some time to pause here. Okay. All right. So let me see where we're at. We did this already. I kind of already did this. Then we'll talk about growth rates. I'll do one more thing before we dive into growth rates, just to reiterate and maybe give you a good visual. So when I'm talking about this investment in the capital and kind of the output we were getting per worker. So if this is what it was before, I really just want to highlight this. If we keep investing the same amount into capital, before what was the marginal output or kind of our marginal benefit? So whatever the slope was. Well, what has now happened to our slope? Maybe I should have drawn this a little bit more, but hopefully you can kind of see it's getting steeper. Right? So at the same level of capital investment, the additional output we're getting is now higher, right? That's kind of why we saw that outward shift, excuse me, in our marginal benefit curve when we were thinking about the allocated efficient point. Okay. Any other questions? Okay. What else do I want to say? Oh, another way of thinking about this is also, I'm kind of highlighting the changes in the marginal output, but also notice if I keep investing the exact same amount, yes, my marginal output is going up, but also just my general output is going to be higher at that point, right? So why do we care about this, right? Why do we care about this capital investment and that technology changes can lead to higher levels of capital investment? Well, investment into capital should result, this was the idea that I'm investing into things like research and development that are potentially going to have cause increases in future output as well. So we'll start to talk about things like growth rates. Economies want a high growth rate. If I only invest into consumption products, I'm consuming everything I produce. There's nothing left over for tomorrow. I'm going to keep producing the same amount year after year after year. As I start to invest into capital products, and here this is, I changed this earlier, so I'll go to what the slides looked like when I posted them and kind of add this in and explain why I added these in before class. So whatever our current output is, so this is a little, as much macro as we'll get is probably this chapter. You'll dive into these topics again if you take 252. But a measure of output for economies is something called GDP, or our gross domestic product. So if we take whatever our current or old gross domestic product is, or our current output, multiply that by 1 plus whatever our growth rate is in the economy. So this is kind of being impacted by how much we're investing in the capital, and then raise that to the power. So notice GDP might not reflect investments in research and development. I might not get anything, any current output out of research and development, but I'll get subsequent increases in output. So whatever that growth rate is, we would plug that in here, take 1 plus the growth rate, raise it to the power of however many years we're trying to project out, and say our new GDP in 10 years, given this growth rate, we can use this formula to calculate that. This will look very similar, and I'll give you an example of here in a second, of interest rates, right? Or investments into interest rates on loans, or investments into the mutual funds or something like that. So I'll paint this in a slightly different context in a second. But for right now, we're just going to think about it in terms of an economy and how we could compute new GDP based off of our old GDP, the current growth rate, and how many years out we're trying to project. So there's a general rule of thumb that every, what doubles, how many years does it take to double your economy or GDP, would be 70 over the growth rate. It's not exact, but it's roughly, and where that comes from is some complicated math that I'm not going to expect you to know. We're not going to waste time with. If you're interested in it, office hours might be a good time we could talk about it. But this is kind of a general rule of thumb. I won't likely ask you a question related to, I won't ask you a question related to this idea of doubling, but I might ask you a question of calculating what GDP would be based off of a growth rate in a number of years. So this formula will be something that you want to have for that module 2 quiz in the exam. Okay. So what I had changed earlier is when I say the growth rate up here, in the actual formula, you would plug in the growth rate in decimal form. The rule of doubling, you're thinking about the growth rate in terms of percentage. So I will make it very clear, like what, give you the growth rate and make sure you know that it's so supposed to be in decimal form for this formula. So this would be like if the growth rate was 10%, we would put in 0.1, right? Kind of converting for percentages to decimal, right? So with this equation in mind, right? Do not underestimate the power of compound interest, right? or don't overestimate the power of a compounded growth rate. How quickly a GDP can grow, right? If even there's a small change in that, or sorry, how much more the GDP can be if there's even a small change in that growth rate. So what I have on Canvas and right here is this interest rate example. So before we go there, I also have this up here just as kind of a reference. I thought this was kind of interesting, and the data is a little bit older. It doesn't have like the most current years, but if you look at like any 10 years, so obviously like this is the S&P 500, it has its ebbs and flows, but over time, right? This is kind of prior to the pandemic. Over any, this entire time period, you get about a 10% return on the S&P 500. So if an economy could get a 10% growth rate, they would love this, right? And we'll kind of, I'll use this other file to show you why. Whoops. Let's go to the homepage. It's under Module 2 materials, but I also posted it right here so it's easy to find. So if you click it and then hit download, it'll download this file for you. If you just view Excel files on Canvas, you can't access the cells within them. So I want to be able to do that. So I downloaded it and I've got it here, okay? Now, I'm not expecting you guys to do this work in Excel. I'm just going to use Excel to do the math for me and show you kind of, I don't know, maybe a glimpse into how powerful Excel can be. I would expect, as you progress through Kelly, you're going to be encountering the use of Microsoft Excel, if not more complicated programs moving forward. This is a quick glimpse. And, I'll try to find some resources that if you're not feeling like you have used Excel a lot, that might be I don't know, almost like a free kind of tutorial of learning to use Excel, because it really is going to be valuable outside of this class. It'll be valuable in your everyday life. I use it all the time, and I'll kind of show you one way which you could use it relating to the content we talked about today. So here, instead of thinking about this in terms of the GDP, which we can, in fact, here I'll do, oops, old GDP, growth rate, number of years were the three things that we needed. If I can get this, there we go, to compute what my new GDP would be, okay? So let's say my old GDP, just to make some easy numbers, is $1,000, right? Growth rate using that mutual fund average was 10. Although I said, if I had a 10% growth rate, in my formula, I should actually be using the decimal form or 0.1. And then maybe I want to project out, I don't know, something like 20 years. Right? In fact, actually, let's just do something, because I'll convert this. Let's just do 4 years. Pretty short amount of time. Okay. So I can use Excel as my calculator and say, okay, if I want to project out, if I have an initial GDP of 1,000, so I just select that cell, I've got $1,000. That's going to get multiplied by 1 plus the growth rate, which I have in this cell. When I click on the cells, it just puts the reference in there and it uses the number that's in that cell. And then on a calculator, you could take something to the power. In Excel, you use this little, like, I don't even know, caret or whatever it's called. And it's to the power of however many years out we're trying to project. So if I had a GDP of 1,000, maybe this is like not a country's GDP, but maybe a high school student's GDP or something, times 1 plus the growth rate to the power of the number of years, in 4 years, this $1,000 would become $1,400, right? Which, pretty sizable increase, right? So I always use this example, and instead of thinking about GDP, I just think about this as the amount invested. So I always say, if you were coming out of high school, I know graduation parties, people give you money. Let's say you get $1,000 at your graduation. Instead of like going and blowing it on, I don't know, a used car, which is maybe what I did, you could have invested it into mutual funds or that are tied to the S&P 500. If they on average return about 10%, if I were to keep that throughout my college career, at the end of it in 4 years, how much money would I have? I'd have $1,400. I make $400 off that. Now, that's a pretty sizable increase, right? Just from 1,000, I now have 1,464, right? So what did I gain? Well, it was my new minus whatever I invested. I made $464 over that 4-year time period. Okay. Now, if I'm not just dealing with high school graduation money, let's say, I don't know, I somehow get pretty sizable amount of money, $10,000. I don't have any bills that I need to spend it on. I can invest it. If I can put it in the S&P 500, keep it for those 4 years of college, I will make what? $4,641. It's a pretty good chunk of change to have then they're waiting for you. Okay. Now, you can play around with this. 10% is a pretty high growth rate. I think my last section, I can cheat, but I looked up like what current CD rates are. So that's like a guaranteed, almost like no risk investment. I think it was like 5.5%. So this is what, 0.055. Whoop. And you could say if I had $10,000 and I put it into a CD in 4 years, how much would I make? 2,300. Well, that's pretty good for a, having a low, almost no risk investment, right? So sorry for the delay again. Should be the last time I have to keep the lights back on. So you can kind of see even at lower growth rates, I can still make a pretty good amount of money even in a short time period. But one thing that's kind of interesting is let's say the growth rate was really low, like 1%, right? This is like a, I don't know, a savings account or something like that. I'm not going to make a lot of money. Like if I invest, let's say $1,000, I'm only make $40 over those 4 years. However, even small growth rates, if I can keep that money there for 20 years, now I'm making 220, right? Or quite a bit, 200% return on this. So even at small growth rates, that can lead to pretty high amounts of money relative to the initial investment over long periods of time. So this other sheet that I have here, I kind of built this out. I did some things with Excel so I could copy this over. I could look at a different number of years. I could look at different interest rates, which can be thought of as different growth rates. Okay? And I just chose $1 invested. You can kind of see if I have a relatively low growth rate or interest rate, even over 35 years, I'm doing what? Doubling my money. Well, what was that rule of 70 we said? If I took 70 and divided it by the growth rate of 2%, that's how often it would take to double. Sure enough, that would be 35 years. So $1 would double in 35 years at 2%. If I instead had, I don't know, 10%, well, when should it double? 70 over 10 would be 7 years. So there, $1 should become 2 in 7 years. Once again, it's rough, right? It's not quite doubled, but it's pretty close. It's an approximation. Okay. And you play around with this, different amounts invested, you can kind of say, oh, how much would I have in 4 years at different growth rates if I invested 1,000, 5,000, etc. Right? So this is kind of an interesting table you can play around with to look at like the, payments. I did, this sheet here. And in fact, well, I'll save this back on my personal computer and post up this file again, but with this additional sheet as well, so that you have access to both of these. Okay. Other than that, so that should do it for module 2. Are there any questions that anybody had? Want me to revisit a topic? Okay with this? Okay. So the one thing we haven't done, and there's only 2 questions here today, so we'll do a little bit of review here at the end of class. This should also help you get those easy participation points. Let's look and see what the questions we have in the participation quiz are. So let's say I have 2 goods, nuclear and coal power. Yeah, nuclear and coal power. I don't know, I use examples that I can't hardly say the word. Nuclear power is on the x-axis. I guess this is also, I came up with this well before all the current events. So I don't know if I'm, this was foreshadowing or what, but, and let's say there's a technology advancement that only impacts nuclear power, right? So, and we're putting nuclear power on the x-axis. So here, what am I thinking about? I've got nuclear power on the x-axis, coal power on my y-axis. So here was my production possibilities curve before. if I have a technology change that only impacts nuclear power, so this is one we didn't work through in class. Oh, this is my x-axis good. What's happening to my production possibilities curve? Well, here it's actually becoming, so if let's see if I can get here's the slope, and then here's the slope. So I try to draw this to show you like it's becoming flatter, right? Whatever good sees the technology change or advancement, well, once we get, again, we said we can get all this information graphically, but intuitively, if I am looking at the good that has a technology advancement, that's the good that's actually going to become relatively cheaper, or the marginal cost should be going down, right? So here, my production possibilities curve is becoming flatter. I think that's what the actual question asked. But an additional question I could ask is, what's happening to the cost of nuclear power? Well, this is flatter, it's closer to zero, so the cost of that good that had the advancement in technology is actually going down. Follow-up question could be, what's happening to the cost of coal power? Well, remember, the cost of coal power would be cost of my y-axis good is 1 over the cost of the x-axis good. So if this is going down, my fraction is going up, right? So this technology advancement would make my production possibilities curve flatter, which would represent the cost of nuclear power is going down and the cost of coal power is going up. Okay. Any questions on that? I'm not going to draw it out, but just to kind of connect what we were talking about earlier as well. If the cost of nuclear power is going down, what should happen to the allocated efficient point? We should actually be moving to a higher amount of nuclear power, right? We would draw that kind of cost curve was now lower. Our allocated efficient point where marginal benefit is equal to marginal cost should now be at a higher quantity. Okay. All right. So we've got what? It becomes flatter. So the next question kind of combines two concepts into one. So we're going to have two graphs to understand this. So the first is, I have this technology improvement. Investing the same amount into capital per worker is going to result in more or less output per worker. Now here, once again, I'll draw it out for you. But if I have technology improvements, the same amount of invested that I had before should now lead to higher levels of output. So hopefully an increase is an easier one to kind of understand here. Now, whatever country or firm experiences that technology improvement, are they going to be more or less likely to have a comparative advantage in that good? So this first question is talking about that macroeconomic PPC. This second question is just talking more about, when we're comparing the original production possibilities curve that we were looking at, the non-macroeconomic one. So we have two ways of understanding this. So the very first one was, if I'm thinking about capital investment per worker and that resulting output per worker, that was our macroeconomic production possibilities curve, which was telling us something about the marginal benefits, of investment in the capital per worker. If I have a technology change, we said it would look something like this, so that at the same quantity of capital, I am now getting more output per worker than I was before. Now we could also say it's not just an overall higher total amount of output. We said here, this is becoming steeper. So if it's steeper, we said that this slope of a macroeconomic production possibilities curve was telling us something about the additional output. So we're not only getting a overall higher total amount of output, but that last dollar invested in the capital, it's leading to a higher additional amount of output as well. Okay. All right. And then the second part of the question, if we had whatever good was, well, let me do this on a separate page. I'll do it reverse. It doesn't matter what axis we put it on, and I did one earlier with it on the x-axis. So let's say I've got some good x, and then I have this good that experienced the technology change. Right? So here's my production possibilities curve initially. Here, after that technology change, whatever good that is impacting, what's happening to the cost of the good that didn't experience a technology change? Well, if I look at the same quantity, right, whatever the cost was before, that slope is now steeper, right? So the cost has went up for my x-axis good. So cost of our x-axis good went up. But I was asking you about, are they more or less likely to have a comparative advantage in the good that experienced the technology change, which is on our y-axis? So if I didn't allow you, if I didn't make you choose, I gave you this visual and I put the good that had the technology change on the y-axis, I can't just look at the slope because that's the cost of my x-axis good. If I want the cost of that y-axis good, it would be 1 over the cost of my x-axis good, right? So if the cost of this x-axis good was going up, right, my production possibilities curve was becoming steeper, the cost of my y, 1 over a higher number, is actually going to be a lower cost to that y-axis good, which means if I'm the country that has this technology change, for whatever good that is experiencing that technology change, my costs are lower, it's going to be more likely I have that comparative advantage now. Okay? So if I can invest into products or I can put money towards trying to come up with these new technology advancements, whatever good those are, I'm more likely to have comparative advantages in those products moving forward. Okay. Any questions there before we keep moving? Okay, so it's going to be what? We said it's going to increase the output per worker, and they are more likely, right, to have that comparative advantage. So kind of prove this to ourselves, hopefully, right? Comes flatter, increasing more. Okay, so those will be the answers for the quiz associated with today's content. That should kind of cover it for everything that I wanted to get through for Module 2. We'll pick up tomorrow with Module 3. I have Module 3's reading up there due before we start class tomorrow, right? I also put up Module 4. That'll be due before we start class on Monday, but that is currently available if you want to get ahead and kind of start working on things. Other than that, Module 2 quiz due by the end of the week or end of the day Sunday. That's now available as well. I would highly suggest, instead of starting that like right now, make sure you're reviewing these practice problems. Also, after that first module, I said I'd start giving you these solutions. So it's how you would work through kind of more detailed solutions, each one of those. I would go through all these questions and go through those materials before I sat down to take that Module 2 quiz, and then subsequently doing the same for all of the future modules and module quizzes as well. Okay. So I'm going to end the recording here.